My name's Ben. I'm an engineer here at Dagster. Mostly been working on the cloud end. And today I'm going to be walking through kind of a high-level demo of Dagster, starting with, very brief kind of overview of, where Dagster fits in the data platform, how we think about orchestration, and then moving into kind of building a basic data platform, data pipeline using Dagster, and then kind of seeing how that would expand out to a more mature data platform. And then after that, we have plenty of time to answer any questions that might come up over the course of the demo, or sort of anything related to Dagster or Dagster Cloud. So I'll start off here with just a single slide to kind of give some background to Dagster and the way that we think about things. So in general, we believe that the goal of a data platform is to generate data assets. This is a pretty generic term, and this can mean any sort of persistent data from a table, maybe that's in Snowflake, to a file in S3, to a notebook, maybe for BI purposes, to an ML model. Any sort of artifact that's used for some purpose that's persistent is a data asset in this context. And data assets have dependencies. An ML model might depend on the training data that you use to build it. And maybe that training data is actually created by transforming some data that we're ingesting from another source. So there's a clear set of dependencies here between our data assets. And the role of an orchestrator in this ecosystem is to create these assets in sequence. And there's a couple different ways that you might do this. If you're kind of approaching this having no orchestrator, and sort of a simple set of assets and asset dependencies, one tool you might look to is cron. If you have an asset B that depends on an asset A, you could use a cron schedule to run a task that would materialize or create asset B an hour after you created asset A. And this works in a very basic case, but it's not very robust. If your task to create asset A would fail, or it takes too long, kind of going beyond that hour that you expect, that's going to cause issues. It's particularly tricky to scale this as the number of dependencies grows and your set of assets gets more complicated. You're going to start to have to manually schedule things in a very complicated manner. So this is where tools like Airflow come in, and why folks might turn to a tool like Airflow. You can tell Airflow to run the task to generate B after the task for A, and this is a lot less fragile. If the task for A fails or takes longer, that's totally fine. Airflow will handle a failure properly and not run the downstream task, or it'll wait for your task to complete before running the one further down in sequence. But Airflow is an older tool, and developers tend to find frictions with it over time. It's in particular designed to run production code, so it's tricky to run locally. It's hard to have different environments, like a staging environment, a production environment, and it's hard to unit test the sort of development flow that you kind of expect in a software engineering world. And it also doesn't really have a first-class concept of assets, which is kind of the entire purpose of orchestration. All of the kind of core abstractions in Airflow are built around tasks rather than the assets that they produce. So we kind of view Dagster as the next step in this evolution. It's focused primarily on data assets and also on fixing some of these problems with the development lifecycle, which hopefully you'll see in today's demo. So to kind of illustrate this, let's walk through building a very basic pipeline from scratch using assets. In particular, we'll be using Dagster's software-defined assets, where we define our assets in Python code. So here we have an empty Python file in our editor, and we'll start by importing pandas and the asset decorator from Dagster, which will let us define software-defined assets. We'll create our first asset, which just looks like the asset decorator applied to a Python function. So we'll call this country population. We'll make a kind of a very simple pipeline, which will pull some population data and do some very basic analysis on it. So here we have a very basic signature for software-defined asset. It's just a Python function. The name of the asset is the name of the function, in this case, country population. The type of the asset is pandas data frame, and the body of the function, which we haven't defined yet, is what's going to actually define how our asset is created. So here I have a Wikipedia page that lists some population information for various countries. So let's just pull the data down from this page. So we can get a data frame by telling pandas to read from this Wikipedia page and grab the table. And we'll actually go ahead and, just because the column names that are going to be automatically generated are going to be a bit messy, let's go ahead and relabel those columns and then return the data frame that we just generated. And for good measure, let's have a little comment here. So this is all we need to do to generate a basic software-defined asset. And we can actually go ahead and materialize this asset by running Dagit, which is Dagster's kind of UI interface, and pointing it at our Python file here. So this is going to spin up a local web server, and in our browser, we can open it up. And we'll see here, this is our asset graph, which shows each of our software-defined assets and the dependencies between them. Here we just have the country population asset, which we just generated. We can go ahead and select it and materialize it. Under the hood, Dagster is going to figure out what computation is needed to regenerate these assets and then queue that computation. So here, this is where all of our compute steps would show up. We only have one here. This is where the logs would show up again. This happened pretty quickly, but we see that our run succeeded and our asset was materialized. So the logical next step here is maybe to build an asset that depends on our country population asset. So let's go ahead and define another asset. Let's call this continent population, which will just aggregate the country population into stats for each continent. The only difference here is that we'll actually define an input to our Python function here, which encodes the dependency between our two assets. So here we use country population as an input, and this is going to let Dagster know that there's actually a data dependency between these two assets. So let's have a comment, and let's just group by the region column in our country data and kind of sum up the population. If we go back to our Dagster UI here, and we go back to the asset graph, we can reload, and we'll see now we have our new continent population asset here. We can see, the country population has been materialized since we ran it just a couple of minutes ago. So we can just select the continent population if we wanted and rematerialize it. Since we've already materialized the upstream asset, it'll just use that prior cached value. And great, the run has already succeeded since it was a pretty simple computation. Of course, we could easily rematerialize all of them and run both steps in sequence if we wanted to. So this is, a pretty bare bones example, but we're already kind of seeing what the differences are between Dagster and a more task-based orchestrator here. In a task-based orchestrator world, we would have to, create a task to create the country population data. We'd have to fetch the data, explicitly store it somewhere, define another task to read the data from wherever we stored it, modify it, store it again somewhere else, and then, explicitly define a pipeline with our tasks in order. But a lot of that's being done for us by Dagster here. The I/O between each of our assets is happening automatically, and the ordering is also happening just based on the data dependencies that we've encoded between our steps. So let's take a step back, and this file that I've been writing is actually in the context of a larger project. So we can see what it looks like to import our assets into maybe a larger data platform. So here we have our population assets. And we actually have this repository file here, which defines an empty Dagster repository. You can kind of think of the repository as an entry point for a bigger Dagster project. So if you have assets coming from a bunch of different places, this is where they'll kind of all come together. So the first thing we'll do is just get our existing assets loaded as part of the repository here. So what we'll want to do is create some population assets, and we'll use this load assets from package module utility function to import our assets from the population Python module. We'll assign them a group name just for organization purposes, and we'll add this key prefix, which I'll talk about a bit later, but this just prefixes kind of the name of the assets. I'll explain why this has been in just a few minutes. Then all we need to do is return our population assets here is part of our repository. And then we can open up Dagit again, and we should see the same set of assets. So let's just make sure that we have those loading properly. Great. So one thing I sort of glossed over earlier is where our assets are actually being saved to and loaded from. I kind of insinuated that the IO is happening automatically, and this is being done using Dagster's IO managers. So the IO managers are kind of a built-in abstraction that lets you decide where and how your inputs and outputs for your assets are stored. Running locally by default, that's just on the file system. But it's really easy, for example, if we wanted to store our assets somewhere more persistent like Snowflake, for us to do that. So let's see what that might look like. We'll start by importing the Snowflake IO manager. And we'll also import the Snowflake Pandas type handler. That'll just let our IO manager know how to handle serialized and deserialized Pandas data frames. And then we'll actually create our IO manager. So now that we have our IO manager defined here, we'll want to bind it to our assets to let Dagster know that these assets should use this particular IO manager. You're able to have a bunch of different IO managers if you wanted to sort of save and load different assets from different places. You know, some might want to live in S3 or Snowflake, or maybe locally is fine. We'll use the with resources utility here to kind of bind our IO manager to our assets. And so we will bind our Snowflake IO manager, and we'll actually provide some configuration here to point towards our Snowflake instance. So here I'm just pulling, you know, all of the credentials from the environment. So if we go back to Dagster here and reload, we're not going to see an immediate change here because we're loading the same set of assets. But if we go ahead and rematerialize our assets, it will actually output them into Snowflake. And we should be able to see that, I think, in the logs here. Great. So we're yielding our data frame outputs, and this is when it's actually going to be written to Snowflake. And so here, if we go back to the asset graph and take a look at our country population asset, we can see we actually get some additional metadata that the Snowflake IO manager is attaching to our asset. So we can see we actually get the columns that are being output into our Snowflake table and the data types of those columns. We get the row count, and we actually get a query here that we can run in a Snowflake against our Snowflake instance to see the asset that we just materialized. So here we're getting all of that country data that was just written into Snowflake by the IO manager. So now let's see what this looks like adding in some additional assets. Dagster also has the ability to integrate with other kind of tools in your data stack. One that's very popular is DBT, which is a SQL-based transformation tool that embeds directly into Dagster. So we actually have a DBT project already set up here, defining a couple transformations from our country and continent data. And if you've used DBT before, they actually have their own kind of graph here that represents the dependencies between their SQL transformations. So here we have, the country population and the continent population being transformed into some ranking information and some cleaned information, and then a summary and some roll-up tables. So we can actually import this entire DBT graph and run it from within Dagster. So let's see what that looks like. So let's first just specify where our DBT project is located relative to our repository file here. And then we can actually load our DBT assets. Call this transformation assets using this load assets from DBT project utility. So we'll specify our DBT project directory. Our profiles directory is going to be the same as the project directory. And then we'll also add the key prefix here. Just for context, the key prefix here determines which Snowflake schema we're writing to when we're using the Snowflake IO manager. So I'm just writing to our sandbox database. And so, Ben is just the schema that I have write access to. So that's why we're using it as the key prefix. So this is all we need to do to kind of load our DBT assets into Dagster. Dagster will parse the project files and automatically build software-defined assets associated with each of the tables that DBT is going to produce here. So let's go ahead and add our transformation assets here. And we'll also need to bind a DBT resource. So we'll set up a DBT CLI resource, which will tell Dagster that we want to execute DBT locally using the CLI rather than using DBT Cloud. And we'll just need to point it at the same project and profile directories here. So if we go back to Dagster, to the asset graph, let's go ahead and reload our definitions again. And provided I did everything right, we should see our DBT assets appear. Great. So, here we have our DBT assets downstream of the Python assets that we wrote earlier. And, you can even see we have some metadata attached, for example, showing what that DBT transformation looks like for each of our individual assets. And, if we wanted to, we could rematerialize everything, which is going to first run our Python assets, as we'll see, our country population, and then our continent population. And then it's going to invoke DBT to generate all of those downstream assets. While we wait for that to run, let's also pull in a few more assets that were kind of predefined here. So we have some forecasting assets that perform some very basic population forecasting. This is just going to be pulled from another Python module, and it's going to depend on those population assets that we defined earlier. So we'll grab those and add them to our repository definition here. And while we wait for this run to complete, let's go back to the asset graph and reload and just see what those forecasting assets look like. Great. So here we can see we have our forecasting assets. So it sets up some features based on the country and continent population data, creates an ML model, and then creates a forecast. A lot of this is, kind of mocked out, but for sake of the demo, let's say that, we wanted to regenerate this population forecast. How would we go about doing that? We could choose to rematerialize all of our assets, but this is kind of an expensive operation. So one thing we can do is, go to this forecasted population asset. We could view it in the asset catalog. This is kind of built into Dagster and shows us every time this asset has been materialized and some of the metadata associated with it. We haven't actually materialized this asset yet, so we don't have any data there. But we could go to the lineage tab and view just its upstream dependencies. And from here, we could just rematerialize that forecast and everything that it depends on, rather than our entire asset graph. if we wanted to abilide going to this, lineage page every time we wanted to do that, we could actually define a Dagster job that just rematerializes our forecast and everything that it depends on. So let's see what that would look like. To do that, we can use define asset job. This is just going to build a job definition that will rematerialize a fixed set of assets. So let's call this update forecast. And provide a selection of assets to rematerialize. So here we can use an asset selection. We can specify the asset keys that we'd like to rematerialize. Forecasted population. So here we're just specifying that forecasted population asset, and then we can actually tell Dagster to grab everything upstream of that. So if we define this job and reload our set of definitions again, we should see in the sidebar, we'll now have our job, which will just rematerialize our forecast related assets. So you can see the other assets that we don't depend on, these are just kind of linked out so we can view them externally, but they're not going to be recreated by this job. Now, this is all well and good. We can, on a whim, update our forecast. But if we wanted to do this on a regular cadence, we might want to attach a schedule to this job to have it update automatically. So that's pretty easy as well. We can wrap our job here with a schedule definition pointed at this job, and then give it a cron schedule. To run, let's say, once every hour. If we go ahead and reload our project again, we'll see that this job will also have a schedule attached to it. So this way it'll run every hour automatically, just rematerializing our forecast and all of the upstream assets that it depends on. So here we have our hourly schedule that we can toggle on. And now we're kind of off to the races. We can have our forecast regenerating automatically every hour. So hopefully this gives you kind of a brief overview, a brief idea of Dagster's programming model and what using Dagster, both kind of from the Python end and also from the UI end, looks like.